Yes, today we are going to talk about a Fourier transform. So what is Fourier transform? A continuous representation of a non-periodic signal as linear combination of complex exponential. Okay. Uh, so Fourier transform is what? It is a representation of non-periodic signal, just like I told you about Fourier series. Fourier series is what? Fourier series is used to find out or to represent any signal in terms of sine and cosine. Okay, and this is a Fourier transform is used for non-periodic signal. Okay, what is a periodic signal? As you know, this is periodic signal because cycles are repeating, and signal like this, like I mean, there is no cycle. I mean, starting point until end point, there is only one cycle, we can say, and there is no repetition of cycle. So this is called non-periodic signal. So to see how many in easy language you can say how many sine or cosine signal are present in a non-periodic signal, then we use Fourier transform. Or more technically, yeah, we say to represent a non-periodic signal in terms of complex exponential. What is complex exponential? If you know, if you, I think you have heard about this formula, e to the power jt or it. So it is what? Cos t plus j sine t. What is this? This is Euler's formula. Okay, so you can see here exponential signal is a combination of cos and sine. So Fourier series is used to represent a non-periodic signal in terms of complex exponential, and this is the formula. X is the signal, and I want to represent this signal into complex exponential, or you can say in easy language, in another word, sine and cosine. Then we use Fourier transform for the non-periodic signal. Okay, xt e to the power minus j omega t dt. This is general formula. And xj omega is what? Xj omega is Fourier transform of xt signal, and this is inverse Fourier transform. Okay, if inverse Fourier transform is not in your syllabus, means if you have the Fourier transform of any signal, then you can come back into the xt signal, time domain signal. This is frequency domain signal. This is xj omega is what? Frequency domain signal, or you can say this is time domain signal. So we go to the example. Now this is the example here. Find the Fourier transform of the following signal: e to the power minus at ut, and where a greater than 0. Okay, so I solve this example over here. Question is find the Fourier transform of xt, and xt is what? E to the power minus at ut. So solution, what is the solution is like this. We know the formula for Fourier transform, very easy. Fourier transform as comparison to Fourier series is easy, you can say. So minus infinity to infinity e to the power, first is xt, we have to write xt signal, and then e to the power minus j omega t dt. This is Fourier series. Now xj omega. What is xt? Xt is this signal. So we have to write down here the limits of the limits of xt signal here. Here we have to write down the limits of this signal. So how to find out the limit, the daira of xt? Now see here, e to the power minus 80, this signal you have seen in chapter number 2 in spatial signal. The power minus 80 looks like this. And second signal is ut. Ut signal is what? Unit step signal. Unit step signal is like this. Its value is 1, its value is 1. This is time, and between these two multiplication is there. E to the power minus 80 multiply ut. So multiplication is there. Multiplication of signals in chapter number 3 you have seen mathematical operations of signal. So we have two signals, and we are doing multiplications. We are doing multiplication. Now we have to find out the daira. We have to find out the limit after the multiplication. So this signal, first signal, this signal is present after 0. Okay, this signal is present after 0, or adds from 0 to infinity. It is going 0 to infinity, from 0 to infinity. And second signal is 0 before 0, and it is 1 from 0 to infinity. So after the multiplication we can say this signal, xt signal starts from 0 and it goes up to infinity. It goes up to infinity. So this is the range of xt signal. So we have to write here 0 and infinity here. This is most important point here. If you do a mistake here, then your whole answer will be wrong. Then after this, inside the integration, write down the signal e to the power minus 80 ut multiply e to the power minus j omega t dt. Now this step, second most important step. Now inside the integration, what we do, we write the equation of the signal. We write the equation of the signal if signal is changing continuously. Now this signal e to the power 80 is changing. The value of this signal is changing continuously. So for such type of signal, we write the equation. So equation of this signal is e to the power minus 80. So I write e to the power minus 80 here, and this is 0 to infinity. But second signal ut, what is ut? Ut signal you can see here, it's constant from 0 to infinity. The value of this signal is 1, and it's continuously 1. It is a constant value. So if the signal has constant value, then inside the integration we directly write the value of that signal. I repeat, if the signal is constant and you want to write down the signal inside the integration, then directly write down its value. Write down its value. What its value is? Its value is 1. So I am writing 1. So 1 multiply e to the power minus 80 is e to the power minus 80, and then remaining part is this one. Remaining part e to the power minus j omega t dt. Okay, now next point. Next point is in chapter number 1 you have seen e to the power a multiply e to the power b is what? A plus b. Now same here. Now you can see this part. Sorry, I'm writing first 0 to infinity, and I'm writing like this. Minus sign is common in both, so I'm taking minus sign out. What is remaining here? A is remaining, AT is remaining, but you can see here in both the part T is also common. So I'm taking T this side, common. Okay, so what is remaining here? Here is A plus what is remaining here? J omega and dt. You can see very carefully. Minus sign in T, I common. I took common minus sign. t. So minus sign here, t I took in the last. Why I am taking t in the last? Because I am making this formula, e to the power nt, e to the power nt. I am trying to make this formula. Okay. Okay. So in this formula, you can notice t in the last. That's why I put t in the last, and this complete one. This complete one is what? N. This complete one is what? N. Okay. So what is the and you know what is the integration of e to the power nt? E to the power nt divided by n. This is the formula. So put this form, use this formula. So e to the power minus a plus j omega t divided by minus a plus j omega, and then 0 to infinity is the limit. Okay. Now I am taking this number out of the bracket. So I am taking minus a plus j omega, and now put the value of infinity in place of t. Okay. So e to the power minus a plus j omega in place of t infinity minus sign. Then in place of t, in the second case, put 0. We know about it. Okay. And then 1 divided by minus a plus j omega. This is what? E to the power minus sign, and if you multiply a plus j omega with infinity, it becomes infinity. And if you multiply this one, e to the power minus a plus j omega with 0, so it is minus 0 or 0, both has same meaning. So I'm writing 0 here directly. And e to the power 0 is what? E to the power 0 is 1, and e to the power minus infinity is 0. So what is the final answer? 1 divided by 1 plus j omega, and this is 0 minus 1 minus 1. So minus minus cancel, and this is the answer. So this is Fourier transform of xt signal. This is Fourier transform of xt signal. Okay. You can skip some steps. If you know the steps, you can skip. Okay. No need to solve step by step. You can solve some small steps in your mind, and then you can write the answer. And this part to find out the range of xt signal is not important to write in exam, but if you can solve in your mind, then directly write 0 to infinity. Okay, the limit of xt signal, if you know, then directly write the value. No need to find out and make the graph. Okay. Now after this, you can see I have solved this example step by step here, and one more example for you, example number 2. Okay, one more example to find out the Fourier transform. Now example number 4.29.1, you can skip this example because it is very lengthy. Okay, you can skip this example. And example number 4.4, this shows that means that this is a square signal. This is a square signal in time domain, and this signal is the combination of these frequencies. Okay, these frequencies. This shows the means square signal. This one cycle is made up of these signals. Okay, so this is for the theoretical part, and in the next video we will see properties of Fourier series and Fourier transform.